Next week. Okay, so hello everyone. Welcome to another Python meeting session. Today we have Sebastián Ramírez again. He's the first one of us who is going to give a second talk. So thank you, Sebastián. And he's going to tell us a little bit about Bash. And well, he's the expert, so I will let him talk. Sebastián, you have 15 minutes.
Thank you. So, hi everyone. Today I'm going to teach a bit about Bash scripts, also about the terminal and basic usage of some commands more than ls or cd. Um, so here is a brief list of commands that I will show. They are pretty easy to use and really useful. So to start off, first to see what we're dealing with, I will be showing, for example, this orbits file. This is just my CSV that I produced with the Exoplanet archive. It has a list of multiple planets of outer solar systems. And we will see what we can do with this. So to start off, if we're in the terminal, if we are in a cluster, for example, and we don't have like easy access to things like in our computer, like to open stuff quickly, we can use some commands that can preview a bit of the file. For example, the first one is head, which shows the first 10 lines of our file without having to open it, without having to load everything. For example, if the file is really huge, if it weighs like 100 megabytes or something, and it will take some time to load, it's easier to just see the head of the file and also the tail. So tail shows the last 10 lines of the file. So as you can see, these are different lines. First, we have the header of the file, and then the end. We can change the number of um, lines that we show, for example, with the end argument. If we want to see only 2 lines, we can do -n2 and the file name, and it will print only 2 of these files. So that's a really useful command. Another one is the WC, which is basically a like word count, I think, which shows the number of lines, the number of words, and the number of bytes in a file. So if we do WC orbits, it will show the number of lines, 2000. I think that's the word count, I'm not sure, which is 3000, and the number of bytes. If we just want to see the number of lines, we can do -L, and it will print only the number of lines, as you can see in here, that is 2000. Another command is to search by words in a file. For that we can use the grep, which is close, but it has more functionalities than doing Control F on a typical file. So if we do grep Trappist to search for the Trappist word, we can search everything that matches in here. So it only prints those that have Trappist. If we have caps or no caps in our names or something like that, we can use the I argument to showcase both the caps letters and the no cap. So if we search for Kepler without -I, we don't get anything because it's with a big K. But if we use the -I, we get everything basically. So that's really useful. Also, we can do with -n to show the line numbers that match. So as you can see here, 544, 553, and so on. So we can quickly go to the file and search for that line. You can do pattern-based searching and multiple other things. Also, we have the find command, which basically prints all the files in the file. We can do something recursive as well. Oh, oh, anyways, find dot. And it shows all the files that were, it's recursive by default, sorry. So it shows all the files. But if we are looking for a specific file or some ending of a file name like CSV, we can do this. Search for a name and with an asterisk meaning everything before. anything. And it shows only the ending in CSV. So orbits and raw exoplanets.csv. If we want to match a specific name, we can also do like without the asterisk. Obviously, there's no file named .csv. There's orbits.csv.
Yeah.
Yep.
So that looks for anything within the environment you're in or everything in your.
Yeah, every subfolder inside the folder I'm in.
Okay.
If I want to go outside, I just do cd to outside. We can do pipelining into of our outputs. For example, if you remember, we have that grep outputs the Kepler systems in this case. But if we do a vertical line, like the OR in Python, it pipelines the output of that into a new command. And if we do WC, for example, it will print all the Kepler files and count the number of lines that have the Kepler word in it. So 1000 in this case. This is really useful, for example, for just looking at how many things match or things like that. And pipelining works basically between every single output of different commands that we have. Yeah.
At the line, can you do it's like an and or an or? Like you find Kepler, and maybe you can put like another grep for another thing inside the Kepler.
Oh, it's more like send this thing into this new command. So, for example, if we have an output in here that is 1000, and that output is just one line, right? So if we do another WC minus L, it's just one line before, so now it gets one. So it's more like take this and put it into this and so on. Also, this is not by default in operative systems, but the tree command is really useful and you can search how to install it. It's really easy. And basically it shows the architecture of your files within your folder. So you can see, yeah, in an easier way in the terminal. So that's a bit about the basic commands that we know of. So now I will show basic shell script building. So for example, shell script must always start with the bash with this that basically says this is a script. And this is like a hello world in Python, basically. So we can define a variable basically with the equal. And then we can do echo, which is print. And to call a variable, we call a $sign system, which is the variable. And if we run that with sh or anything alike, we basically get our first hello world program with a variable. Now, if we want to introduce arguments, like when you do -l or everything like that, we can do these $signs defining variables. So we do sh and our file arguments. And now we have to obviously write which arguments are we using. So for example, our systems, which is orbits, which is TRAPPIST, for example, and the file. And it does the echo, and I wrote something wrong, so I didn't get the grep correctly. I wrote 3 piece. There it is. So it basically replaces this into these commands here. For the basic if-else usage, this is the structure that you must follow. So it's if and open brackets with a space. If you don't put a space, it works badly sometimes. And you put the condition. And obviously the notation is different from other languages. For example, in this case, we can call the number of arguments we have. So if we put 3 arguments in the terminal to call this file, we have 3. Must be less than, that means LT, 2. Then the condition is true, and we call these lines, which is echo the usage, blah, blah, blah. Also, if we have some empty file or a file that doesn't exist, it calls this condition. So not the file doesn't exist, then it calls this. So if I call O4 and we do our system name Trappist and our catalog orbits.csv, it calls all the files again. But if we do it incorrectly, so if we don't call an argument, we have the usage error that we placed in here because we only have 0 arguments. That's the if else. So for example, this is a bigger program that we have where we use the same kind of stuff to make sure that we have 2 arguments. We call the system the catalog, and we plug that into our Python file that it produces a nice plot with those planets. And if I call it O5 Trappist, and I call the orbits.csv, it doesn't work. System. Okay, there it is. So it creates a nice plot. This is obviously our Python file, and it produces the orbits and the evolution, everything like that. Some files, whatever. So that's really nice to like run a Python script from the shell. We just call Python and the arguments in here. And you may ask, like, why do we want to do this instead of just calling the Python file? Well, we can do basically multiple calls for different files. So for example, if we have many systems that we do want to analyze into our Python file, so we have a Python script and we want to plug in different systems, we can have a list of systems that we want, Kepler, Trappist, HD 10180, and plug everything into our script of Python. To do that, we basically need to use a while loop that reads this and plugs that into the Python shell script. So a bit of notation for making a while call. We can do it like this. This is the basic usage. This is the same as a while in Python. While our count is less or equal than 5, we echo the number, and then we increase the count. We can also do this from a file. So while we're reading some file, like the systems in here, we read every single line as line, and here's the file. So if I call this O7 script, it prints each one of our systems. And here is the notation for loops as well. Here is to do a range, basically. This is the C type of counting that you can do as well. So that's nice. So I will use this particular while loop in this script. So we have the same as before. While we're reading our systems, we plug them into the Python scripts and get every single output for each one of the systems. So I call O8, and the usage is system file, catalog file. So I plug systems.txt and the catalog, which is orbits. And that creates the plot for all of our systems that we're interested in. So that's most of it. Obviously, you can do a lot. There's more commands. There's also pattern searching that it's interesting to look at. But that's the basic usage of the terminal more than ls and cd. So thank you for listening. Any question?
I have a question. So it is not very clear to me why, for example, if I want to run a lot of Python scripts, why is it easier to like maybe run through Bash instead of, I don't know, just putting that line?
Yeah, so imagine you're running, instead of 3 systems, 100 of them. So one option you have is to make a for loop that covers everything inside your Python script, inside Python as well. So that may be an obvious solution. But imagine you are working, for example, in a server that has a queue system. So you must do a queue sub to run a job instead of just calling everything. So if you have, for example, 80 cores in a server, and you want to send a script into each core, um, if you send a single Python script, it will be like sequential inside a single core. If you do it with Bash, it sends one to one core, then one to the other, and so on. So that's a really good usage for servers, for example. Um, so yeah, but yeah, if you have like this particular example, it can be done in Python as well.
That particular example can also be done in Python.
Sending to multiple,
But
yeah.
there is another case in that, and it's, I don't know, I work with messy stuff that people have developed over the years. As for example, one code runs with a set of libraries in an environment, but not in another.
Yeah.
And the following code cannot be run here, but needs to be run in another because of incompatibilities between libraries. So, for example, you can use Bash to change the environments that run.
There's also another really particular part of that question is that we're assuming that you're using Python. For example, I work with C code that must be run with the compilation of the code. So if you don't have a Python file to work to begin with, you may want to run other things. Also, we may want to do things outside Python like the check GPU usage in the server before sending a script. And to do that, you do it from the terminal. So not everything happens inside Python. You can do things outside as well. Okay.
I have a question. When you're doing this, can you know how long is it going to take to run? Like, is there like any thing in Bash to tell you how long the script is going to take? Like, for example, if you have a like very long script, do you have like a timer, like to see the progress?
I mean, like TQDM, I'm not sure though. There's the date command, and probably there's some package that you can download and it does. You can also do a basic print. So TQDM is really simple in its basis. So it's really a print that removes each new print every time that you go a step into the loop. So you may want to look at something similar using the date command probably, or something like that. I'm not sure though, if there's like a particular command.
More questions?
Do you know what TQDM is?
Hmm?
Do you know what TQDM is?
No.
Te creo demasiado.
What is TQDM?
What is TQDM? Okay. Like I thought that you were making a fun fact. So TQDM is basically a progress bar that you can put in Python as a package that shows you the progress of some for loop as it progresses, and it also estimates the time that that script will take if you do a simple linear interpolation of the time that you have taken and how many steps are left. And there's a comment from Rohan. A tip for privacy. Okay, that's cool. So there's a program that makes auto suggestions for CSH, which I didn't know of. So I will probably look it up because it's useful. Thank you, Rohan. Well, that's it. If there are more questions.
Okay. Fine. No?
I think that the Bash in Ubuntu by default has autocomplete.
Okay.
Yes. Okay, so thank you everyone for coming. Thank you, Sebastián, for presenting. And we will see you again, I think, next week. I don't know, I'm not sure. We'll see. If you want to present something, please ask us, Sebastián, Matias, or I. And everyone who's watching online, thank you for coming. And if you're watching this video on YouTube, like, subscribe, and leave a comment, share. Maybe in the future, a lot of people will see this video and going to be very useful. So thank you.
Ciao.
Thank you.